Let's talk about 114, S and T, the last two in that list. Kind of misled you a little bit. I didn't mean to. These last two series are actually not geometric, but they're going to be the sum of two geometric series. I did one like this in the lecture video. If you look at part 2 for this section on geometric on series, section 10.2. But let's take a look at S. So T is very similar to this as well. But here's the series, the sum, and I'm just going to go ahead and start with listing the terms out. And if it's geometric, the same value of R must be used to obtain all successive terms in the series that you're adding up. So when n is 1, we'll start with that. I get 1 plus 3 to the first power. That's 1 plus 3 is 4. 4 to the 1 minus 1, 4 to the 0 power is 1. I get 4 divided by 1, so I get 4. When n is 2, I get 1 plus 3 squared. That's 10. 4 to the 2 minus 1, 4 to the first power is 4. I get 10 fourths, which simplifies down to 5 halves. And then when n is 3, I get 1 plus 3 cubed is 1 plus 27 is 28. 4 to the 3 minus 1 is 4 squared, 16. Divide top and bottom by 4, and we get 7 fourths. Okay, so there's just the first 3 terms. You can continue that on. But if you're thinking it's geometric, let's see what the ratio is going from the first to the second term. If I divide the second term by the first term, I get 5/8. In other words, 4 times 5/8, right, is going to give me 5 halves. So the value of R is the value we're multiplying by at any rate is 5/8. However, if I take 7 fourths and divide it by 5 halves, I get 7 tenths, which means 5 halves times 7 tenths is 7 fourths. It's not the same R value. Therefore, it is not geometric. These R values are changing each time. So it's not geometric. Geometric means you have the same R value every time. Okay, so most series are not geometric. Most series are not geometric, but this series is actually the sum of two geometric series that we're going to see are both convergent. And because of that, we can use the following summation properties. First of all, I can split this up into the sum of two fractions, can I? Remember, in general, if you have A plus B over a common denominator C, right, that's the same as A over C plus B over C. I'm just sort of going in reverse, right? And typically, we're looking at adding fractions and we combine them as one, but here I'm going to split this up. And we've used this technique quite a bit in other areas in this course. So I split it up, but then I'm going to actually write that as two separate sums, right? And I can do that provided both of these resulting series are indeed convergent, which they are. And what we'll see then is the first one is, of course, geometric. If I look at the first three terms here, I see that the first term is 1 and the ratio R is 1/4. So I know since R is less than 1 in absolute value that I can now compute the sum. And the sum is A divided by 1 minus R. So A is 1, R is 1/4, gives me 4/3. Over here, very similar. I list the first three terms in this series. The first term is 3. The value of R, that's the same every time now, right? 3/4 times 3/4 times 3/4, right, is again less than 1 in absolute value. Therefore, this is a convergent geometric series. The sum is going to be 12 after I work that out. And so since our original series, all right, is the sum of these two series, both of which are convergent, and we know the sum of each of those series, the sum of our series will be the sum of these two series together. So 4/3 plus 12, which is 40/3. So that's the way you want to do S and T. Again, I apologize, didn't mean to confuse people on that one. I'll need to, for future classes, make a little asterisk or note by these two to realize that they're actually not geometric, but they can be written as the sum of two. They can be written as the sum of two geometric series. Okay, so hope that helps with number 114S. And again, 114T is similar to that one.